Alrighty then, number 23. Use the function g of x right there for 23 through 25. So let's get a handle of what we're doing. 23 says, what are the solutions? 24 says, which is equivalent? And look, it's in completed form. It's a vertex form, completed square. 25 says, identify the vertex. So, how are we going to do it? Well, since I need to get it into vertex form, the smartest way to approach this problem is going to be to just complete the square. To complete the square, what I'm first going to do is I'm going to factor out the leading coefficient. So I'm going to factor out a 2 from my x squared and from my minus 4x. So it'll become a minus 2x. Then I'm going to close my parentheses. I'm going to leave the plus 5 as it is. Now that I've pulled that 2 out, I'm going to actually complete the square, which means I'm going to write this as x minus 1 squared. Minus 1 being half of this number. I'll still have my plus 5, but now I need to subtract this number 1 squared times the leading coefficient of 2. So now 2 in front, x minus 1 squared. 1 squared times 2 is 2, so I need 5 minus 2 is a plus 3. Okay, so there is that. That is my equation. If I want the solutions, I should set that equal to 0 and solve for x. So 0 equals 2x minus 1 squared plus 3. So let's subtract 3 from both sides. We'll get negative 3 equals 2 times x minus 1 squared. Divide both sides by 2, so we get negative 3 halves equals x minus 1 squared. Square root both sides. The square root of negative 3 halves, don't forget your plus or minus the square root of negative 3 halves equals x minus 1. So last step, add 1 over, and look, when you add 1 over, you get 1 plus or minus the square root of negative 3 halves. And if you have a negative and a square root, you can get rid of it by pulling an I out. So our option has to be D. Now you could use the quadratic formula to do this problem as well. But if you do the quadratic formula, your answer looks fairly different. So quadratic formula would be negative b. So there's b, there's a, there's c. So negative b is negative negative 4. So positive 4 plus or minus the square root of b squared, so negative 4 squared is 16, minus 4 times a, which is 2, times c, which is 5, all over 2a. A is 2, 2 times 2 is 4. Okay? So, where now? Let's simplify things. Let's do the 4 over 4 now. Let's just say 1 plus or minus the square root over 4. You have to divide both of those terms by the 4. So I can simplify the left, but I have to make sure I'm still dividing the right by 4. 4 times 2 is 8. 8 times 5 is 40. So the inside becomes 16 minus 40. 16 minus 40 is 24, negative 24. So we get that, and you're like, poopy. None of these have a 24 in it. So you simplify. If you start to simplify, 24 is 6 times 4. So the square root of 24 is the same as the square root of 6 times 4 is the same as 2 times the square root of 6 by pulling that full 4 out and square rooting it. And if you look, here is our, oh no, we still can't see it. So the 24 is that. So now I have 1 plus or minus the square root, oh my gosh, 2 times the square root of 6. I pulled the negative out, right? That negative right there. And that is over 4. And then the last step is 2 over 4 simplifies to a 2 in the bottom. And then you can see that it's that solution right there. That solution was not on the original study guide, so you did not see that solution. So if you did the quadratic formula, you probably didn't recognize that any of these were actually the solution. But D and A, in the options I have right here, are actually equivalent. And you can show that they're equivalent if we focus on this part. Square root of 6 over 2 is can be rewritten. If you wanted to write 2 in a weird way, you could say the square root of 6 divided by the square root of 4, right? Square root of 4 is 2. And if you have that, that's the same as the square root of 6 over 4, all inside a single square root, which 6 over 4 simplifies to 3 over 2. So you can now hopefully see where this 302 is coming from.